Evaluate the integral of the square root of 1 minus x squared dx. First, we draw a right triangle whose one of the sides is the square root of 1 minus x squared. So the hypotenuse is 1 and the side is x. Sine theta is x over 1, so x is sine theta. X squared is sine squared theta, and therefore 1 minus x squared is 1 minus sine squared theta, or cosine squared theta. The square root of 1 minus x squared is now the absolute value of cosine of theta. As long as we restrict the domain from negative pi over 2 to pi over 2, then the square root of 1 minus x squared is positive cosine of theta. The integral of the square root of 1 minus x squared dx is now the integral of cosine of theta dx. But if x is sine theta, then dx is cosine theta d theta. And so the square root of 1 minus x squared dx is now cosine theta times cosine theta d theta. Simplifying this to obtain cosine squared theta and use the double angle formula to rewrite it. The antiderivative is 1/2 times the quantity theta plus 1/2 sine of 2 theta plus c. We then distribute 1/2 to obtain 1/2 theta plus 1 over 4 sine of 2 theta plus c, or 1/2 theta plus 1 over 4 sine of 2 theta is 2 sine theta cosine theta plus c, 1/2 theta plus 1/2 sine theta cosine theta plus c. This is not the final answer because the variable in the original integral is x. This expression is in terms of theta. We need to rewrite these expressions in terms of x. Since x is sine theta, theta is sine inverse of x. Using the right triangle, sine of theta is x over 1, and cosine of theta is the square root of 1 minus x squared over 1. Make sure the final answer to this integral is in terms of x. Simplifying this to obtain 1/2 sine inverse of x plus 1 over 2 x times the square root of 1 minus x squared plus c.